Hello students, I hope that you are good, well and fine. In today's class, what we will be seeing the remaining problems of NCERT exercise 1.1. Okay, so we covered 1 to 12. Yes, so now the 13th problem, what it says show that the relation R defined in the set A of all polygons at S. So my relation is from where to where? It is from R to R, sorry, A to A. This means R must be subset of A cross A. And this set A is what? Collection of all polygons. Collection of all polygons. Okay. So now the relation R is defined as collection of all such ordered pair of polygons such that P1 and P2 have same number of sides. So when do I say that this pair belongs to what in my relation? When the first polygon and the second polygon I have in a pair must have same number of sides. Okay, so this defined relation is an equivalence relation I need to show. So quite simple to need to show that it is an equivalence relation means we need to show it is reflexive, symmetric and transitive. Yes, quite simple. Let us see. So first of all, the reflexive relation. So if you recall, what do we mean by reflexive relation? In reflexive relations, we need to show that the pair with itself must belongs to the relation R. So this means P comma P must belongs to the relation R for every P belongs to the set of what? Polygons. The set A. A set is what? The set of all polygons. Okay. Or you can say P or P1. Okay. In this context, let me write P1. Okay. So P1 pair with P1. This P1 must belongs to the relation, sorry, the set A. Now, how we are going to show? In this, we do not have if condition. That means we do not have any given information. So from where we need to start? We need to start from something we know. We know what we know, that take any polygon, take any polygon, okay, take any polygon with say n number of sides, say, okay, n number of sides, okay, yes, then you can observe then it is having same number of sides as take any polygon, let me name it. So take any polygon, say P, or let me use green colors, say P1. Okay, so take any polygon P1, take any polygon P1 with n, say n number of sides, then it is having same number of sides as P1 itself. Yes, it is true. So this means P1 comma P1 belongs to the relation R. For every P1 belongs to the set of what? All polygons. Okay. So why we say this, that P1 pair with P1 belongs to the relation R? Because the number of sides in this polygon is same as the number of sides in this. Why? Because both my polygons are same. Okay. Now the symmetric. Now symmetric relation. Symmetric relation. In symmetric relation, what we need to show? To show if P1 comma P2 belongs to the relation R, then we must have P2 comma P1 belongs to the relation R. So what we are given with? Given information is this if condition, means P1 comma P2 pair belongs to the relation R. From this, what we can say is that number of sides in P1, number of sides in P1 polygon is equals to number of sides in P2 polygon. Yes, okay. This means number of, this means what? This means number of sides in P2 is same as or equal to number of sides in P1 polygon. And from this, what you can say is that P2 comma P1 is going to belong this relation R. Okay, so whenever you have this information, you will also have this. Okay, so this means it is symmetry. Now for transitive, transitive, to show what we need to show. So first of all, if P1 comma P2 belongs to the relation R and P2 comma P3 belongs to the relation R, then we need to show, or the main thing is to show here, this pair P1 comma P3 must also be in R. So given information is what? This and this. So P1 comma P2 belongs to R. Okay. Another piece, P2 comma P3 belongs to relation R. Okay. From this information, what I can say is number of sides in P1 is same as number of sides in P2. Yes. Okay. And from this, what I can say, number of sides in P2 is same as number of sides in P3. Okay. Suppose P1 polygon have 100 sides. Okay. This means from this must also have 100 sides. Yes. Okay. And number of sides in polygon 2, 100. So this means this will have 100 also. And this is equals to this. This means by default, it will be having 100 also. So every time, whatever you take this side, you will have the same number here. So what you can say is that from both of these statements above, number of sides in P1 is same as number of sides in P3. So from this, eventually we can write that P1 comma P3 belongs to the relation R. Okay. So it is symmetric, reflexive and transitive. This means this is an equivalence relation. Okay. I hope that it is clear. Now, the other part of this question says, what is the set of all elements in A related to the right angle triangle T with side this? Okay, so we are asked that if I want to know pairs, so what pairs? That you say that if this is T is what? T is, as you can see here, T is right angle triangle with side this. Okay, then I need to find what I can put over here. What thing I can put over here, or what polygons I can place here. Okay, that's it. So that this must belongs to the relation R. So what I need is, we know that T is a triangle. Yes, imply it is having three sides. Okay. And we know what we know, that whatever we want to put here must also have the same number of sides. This means this thing or this polygon must also be having three sides. So this imply this polygon must also be having three sides. Okay. Can you name polygons having three sides? Yes. Imply in general polygons with three sides are called as what? Triangles. Yes, triangles. Okay. So I can put any triangle over here and this will always be true. Okay. So T is related to all triangles, I can say. Okay. I hope that the second part is clear. Okay. So this information is just to confuse you that it is a right triangle or with having side this. Okay. So if you try to observe that what we needed just this information, how many sides it is having. Okay. So the T is related to what? The set of all triangles. Okay. I hope that it is clear. Okay. Let us move to the next question. Question number 14. So question 14, what it says, let L be the set of all lines, okay, in XY plane, okay, and R be relation in R. This means R is a subset of L cross L. L is what? Collection of all, or we can say set of all lines. Okay. Okay. Now R is defined like this: collection of all pairs L1 comma L2 such that this L1 line must be parallel to L2 line. Okay, so L1 line must be parallel to L2 line. And what we need to show that R is an equivalence relation. So in order to show it is an equivalence relation, we need to show that it is reflexive, symmetric and transitive. So first of all, let us show that it is reflexive. So reflexive, to show what? That L1 comma L1 pair belongs to R such for every L1 belongs to what set? The set given to us is L. Okay. Okay. So now L. Okay. Now here from where we start something we know. We know what we know, that any line is parallel to itself. Any line is parallel to itself. We already know that. This means L1 is parallel to L1. This imply L1 comma L2 belongs to the relation R. L1 comma L2 belongs to the relation R for every L1 belongs to L. So this means what? So this means what? It is an reflexive. Okay. Reflexive. We showed reflexive. Now, what about symmetric? So for symmetric, to show what we need to show, if L1 comma L2 in relation R, then we need to show then L2 comma L1 must also be in R. Okay, so given thing is L1 comma L2 belongs to the relation R. Okay, from this what you can say is that the L1 is parallel to L2. So L1 line is parallel to L2. In other words, this is same as saying that L2 is also parallel to L1. Okay. Oh, yes. And from this what I can say that L2 comma L1 belongs to the relation R. Yes, if I have two lines parallel to each other, then I can say that this belongs to the relation R. Okay, so it is symmetric also. Okay, symmetric. Okay, now transitive. Transitive. Now to show if I have what? If I have L1 comma L2 in relation R and L2 comma L3 in relation R, then we need to show then L1 comma L3 must also be in R. Okay, so we start from here where this condition, the given condition or the if condition, L1 comma L2 in R and L2 comma L3 in R. Okay, from this what I can say is that L1 is parallel to L2, and from this what I can say is L2 is parallel to L3. Okay, now let me draw. If this is my L1 line, if this is my what? L1 line, say L1 line. Okay, L1, and this is my what? L2 line. L2 line. From here, as we know that L1 and L2 are parallel, this means that they will never intersect each other or cut each other. Okay, okay, now here we are having L3 line, and we know that L2 and L3 will not cut each other. So we know that L1 and L2 will not intersect each other at any point, and we know L2 and L3 will not cut each other at any point. Then we can directly say that L1 and L3 will not cut each other. Yes. So this means from both of these statements what I can say is L1 is parallel to L3. L1 is parallel to L3, so this means it is transitive. So it is an equivalence relation. Transitive. Now what? Now the other part in the question, it says find the set of all lines related to the line this. So if you draw this line, so how if you can you remember how will you plot this line? So quite simple. Put x is equals to 0, then find y. So what will be your y? 4. Put y is equals to 0, then find x. So x will be what? -2. Yes, if you put x -2, you will get y 0. Now plot this 0 comma 4 point and plot -2 comma 0 point. Okay, so -2 comma 0 will be somewhere here and 0 comma 4 will be somewhere here. Yes, now join both of the points, you will get your graph for this line. Okay, so this line is what? Y is equals to 2x plus 4. This is x-axis, this is y-axis. Okay, now find the set of all lines related to this line. So if this is L1, then I need to find, if this is L1, then I need to find L2. What I can fill in this place? This means L1, I need to find all the lines which are parallel to L1. So can you think any line which is parallel to L1? Yes, it is quite simple. Whenever you have what? A line or its equation, then you just put what? Take this thing same, okay, the thing with x variable in it, and then what you will do, just add any number. So any number, any real number. Okay, so we are talking about any real number, any number. Okay, so this means 2x plus c. I am saying that number as c. Okay, c is any number. So your parallel lines will be like these. Okay, So if you put C as 0, if C is equals to 0, then your Y will be what? Or you can say L2 will be what? 2x. If C is equals to 1, your L3, or you can say, or just you say L2 will be now what? 2x plus 1, and so on. You will have infinitely many lines. Okay. So your set of all lines related to this line will be this. Okay. Or let me write in roster form. Okay. So L2 set will be what? Y is equals to 2x plus C, such that C belongs to the set of all real numbers. Okay, I hope that it is clear. Okay, so this the set of all lines will be this. Y is equals to 2x plus C. C belongs to what? The real number set. Okay, okay. Let us move to the next question. Now question 15. Question 15, what it says, if my relation R is from where to where? This set to this set. Okay, let me say this set is A, so this means R must be subset of A cross A. A is what? This. Okay, now relation is given by this. Okay, so we need to choose the correct option. So correct option. So in options we are asked that it is reflexive, symmetric or transitive. So let us do all. Okay, so reflexive, is it reflexive? To be reflexive, what we needed that any first of all, in reflexive, what you need to see, you need to see this set. So this set is this. So now what you will see, pick every element and then pair itself. So 2 comma 2, 3 comma 3, 4 comma 4. Now see that are all these pairs in your relation R or not. As you can see, 1 comma 1 belongs to there, 4 comma 4. Yes, 1 comma 1, 4 comma 4, 3 comma 3 and 2 comma 3, 3 comma 3 and 2 comma 2. Okay, so this means it is reflexive. Okay, so this is what? Reflexive. So option A says it is reflexive. Okay, option B also says it is reflexive. Okay, option C says it is not reflexive, so this means I can eliminate option C. Okay, and option D also says it is equivalence. Equivalence means it is reflexive. Okay, so I can only eliminate this. Okay, now what? Now let us check for symmetric. In order to check for symmetric, if you recall the definition, we have, whenever we have this pair, always start with this pair in R, then see the B comma A. B comma A belongs to the relation R or not. If it does belongs to R, this means your relation is symmetric. If this is happening, then not symmetric. Okay, so let us see. 1 comma 2 belongs to R. 1 comma 2 belongs to R. Does 2 comma 1 belongs to R? As you can see, no 2. So 2 comma 1 does not belongs to R. So this means not symmetric. So let us see. First option says it is reflexive as well as symmetric, but we have seen that it is not symmetric, so I can eliminate this. Now B option says that it is not symmetric. Okay, this might be our answer, and this says that it is an equivalence relation. Equivalence relation means it is symmetric, but we already arrived at this point that it is not symmetric, so I can eliminate this. So my option B will be correct. Okay, by just elimination. But here let me do it by definition that it is transitive also. So for transitive, if you recall, if A comma B belongs to R and B comma C belongs to R, check this and this belongs to R and then see that A comma C belongs to R or not. If it does belongs to R, then it is transitive. If it does not belongs to R, then it is not transitive. Okay, so try pick any two pairs such that the second and the first element same. So 1 comma 2 and 2 comma 2 belongs to R. Now 1 comma 2 belongs to R, yes, as you can see. And now this 1 comma 1 belongs to R, 1 comma 3 belongs to R. Does 1 comma 3 belongs to R? Yes, as you can see. Now 3 now what? Now this 3 comma 2 belongs to R, 2 comma 2 belongs to R. This means 3 comma 2 belongs to R. So whenever you have such two pairs, you will be having this. So this means it is indeed transitive. So the option B is your correct option. Okay. Okay, let us move to the next question, the 16th, and this is what the last question of NCERT exercise 1.1, I think. Yes. So let us solve together. So let R be the relation in the set N. So this means R is a subset of what? N Cartesian product N. Okay, given by this collection of all pairs such that A is equals to B minus 2, and this B must be greater than 6. B must be what? Greater than 6. Okay, so what value I can take of B? So B is what? B can be 7, 8, 9, 10. Yes, because it is from natural number set, and must be strictly greater than 6. So this means 7, 8, 9, 10 and so on. Okay, and we already know that this A and B belongs to what? Natural number set. Okay, set of all natural numbers. And extra condition we are given with this. Okay, now I can write two pairs. I can write a pair, the first element A and the second element B, if this is happening with this condition. Okay, if you try to write A is equals to B minus 2, in other words, what you will have? You will have 2 is equals to B minus A. Yes, this means B minus A is equals to 2, or in other words, the second element in the pairs, the second element minus the first element must be true, 2. Okay, okay, let us see. So try this. So 4 minus 2 is what? 2. Okay, it satisfies this condition. What about this? That the second element, which is B, the second element must be greater than 6. Does second element here is 4, and 4 is not greater than 6. So this is not our option. Okay, now what? Now try this. So for this 8 minus 3, the second element minus the first element is not equals to 2, as you can see, but we want 2. So this means we can directly eliminate it. Okay, now what? Now choose the option D. Okay, now 7, the second element minus the first element, will give you minus 1, which is not equals to 2. We can directly eliminate it. Okay, what about this? What about this? As you can see, this is 8 minus 6, which is indeed 2. Okay, so it satisfied this condition. What about this condition? The second element must be greater than 6. So here the second element is 8, and 8 is greater than 6. Yes, it is true, 8 is greater than 6. So it satisfies both of the condition, this and this. So this means my correct option for this question 16 will be what? Option C. Okay, I hope that you got your answer. So that's it for today. We will meet soon. Thank you.